Nearly all data-driven apps will need to be able to filter data displayed to users. MobileTogether Designer enables developers to implement this functionality in a way that reduces the load on your database servers. This tutorial will introduce you to basic filtering within MobileTogether apps. We will cover a way to filter results without the use of SQL queries. Filtering this way will significantly reduce the load on your server and improve response time on the client app. This method will also allow for instant feedback, returning results to the user in real time as they type their query. In addition to filtering, we will also cover xQuery functions. User-defined functions in MobileTogether provide developers with a centralized location to store the logic behind frequently used and/or highly complex xQuery statements. First, let's load the books tutorial from previous examples. Once again, I have included a link to the project file and data in the description below. The first thing we need to do is make a few changes to the main page. The requirements call for a new checkbox to be created to the left of the Add New Book button, with the search text being typed into the center. When the search checkbox has been checked, the app should hide the Add New Book button, show the search box, and filter the results. Conversely, when the box is unchecked, we want to show all results, hide the search box, and show the Add New Book button. Let's start with the search checkbox. Drag a checkbox control to the left of the Add New Book button and select Checkbox Left of Text. Enter the text Search and set the table column width to wrap content and add a 5-pixel right margin to the control. Next, drag an Edit field control between the checkbox and the Add New Book button. Now select the Add New Book button and right justify it. Finally, add a horizontal line between these controls and the repeating table below. This will help to break things up a bit. This takes care of the positioning and formatting of the controls. We now need to create new XML elements to store values linked to both the checkbox and the search field. These elements can either be added to a new or existing XML tree. Let's utilize the existing persistent tree for simplicity. Create a new persistent element named Search and select Ensure Exists on Load. This is the element which will store the value of the search checkbox. It should be 0 when unchecked and 1 when checked, the default behavior of this control. Link this element to the checkbox. Below this, create another element named Search Text. As you have probably guessed, this is the element that will store the text entered into the edit field. Select Ensure Exists on Load and link this element to the Search Edit field control. As we mentioned previously, we want the checkbox to do a few things. It should alter the visibility of both the Search Edit field and the Add New Book button, as well as controlling whether to display all results or filter them. Let's work on altering the visibility first. Select the Search Text Edit field and locate the visibility property for the column in the Properties pane. It is important to edit the column visibility and not the control visibility. Doing this will allow either the Edit field or the button to take over the entire table to the right of the search box. Click the XPath button next to this property. We will construct a simple xQuery expression to check if the search box is checked or not. Locate and double-click on the search element in the persistent data source. When the checkbox is checked, we expect a value of 1 in this element. Knowing that, the expression can be written to look for that value. If it exists, this expression will return true. Click OK. Repeat these steps for the Add New Book button's column visibility. However, instead check for a value of 0. This expression will return true only if the checkbox is unchecked. The last thing we need to do is modify the onload actions for the main page. Currently, the search element will initialize, but it may not have a value. This will cause neither the edit field nor the button to show up. To get around this, let's tell the page to reset the search checkbox to unchecked each time the page is loaded. Go to the Page menu and select Page Actions. Verify that the On Page Load tab is selected and drag an Update Node action to the workspace on the right. Set this action to update the search element with a value of 0. This will cause the checkbox to be unchecked each time the page is loaded. Go ahead and click OK. Let's run the simulator to test this functionality. Verify the checkbox starts unchecked with the Add New Book button showing. Check the box. You should see the button disappear and the edit field show. Now it's time to set up the filtering functionality. The best way to handle filtering within the app itself when you are not required to go back to the database is to control the visibility of each repeating row. When the search button is checked, each row's visibility property should execute an xQuery expression to see if the field contains the search phrase. If they contain the phrase, they should be shown to the user, otherwise hidden. We are going to accomplish this by modifying the visibility property for the row and executing a custom function that we will also define. User-defined functions are a powerful way to centralize xQuery logic in a single place. Using this will allow us to quickly make changes and tweak how we search for text. To set this property, select the Books row and click the XPath button next to the visible property under Table Row Group. First, we need to check to see if search is disabled and, if so, return true. Locate the search element in the persistent data source and modify the expression to check if the value is 0. This will return true when the checkbox is unchecked and will always display this row. Next, we will execute our soon-to-be-defined function. Let's call it search text in row. Type OR followed by this function name. Set the parameter to a period. Doing this will execute this function and send it all of the data in the current row. Click OK. That is the only change we need to make to the table itself. From here on out, everything will be handled by our new function. Open the Functions dialog by clicking on the XPath xQuery Functions button on the toolbar. Create a new function by clicking on the green plus icon. Name this function Search Text in Row, matching the spelling and formatting used earlier. Set the parameter count to one of a default type, leave the return as default, and click OK. We now have a new, empty function which can be used anywhere in our app. Start by changing the parameter from A to row. Each time this function is called, the content of the row will be sent over and set to this variable. Throughout the rest of this tutorial, we will be building on this function. We will iterate over several variations of this search function until we finally arrive at the final product which meets our original requirements. The first thing to demonstrate is checking only the title for equality. In the contents of the function, enter an expression which checks the row's title element against the search text. This will look for an exact match, including capitalization. Click OK, save, and run the simulator. When you check the search checkbox, you'll notice immediately that all the results disappear. This is happening because we are checking for an exact title match and none of them are blank. Type market volatility. As soon as you complete this title, the results show up. Add a space at the end and it disappears. This demonstrates that our filtering works, however it still needs quite a bit of tweaking. Close the simulator and open the search function by clicking on the XPath xQuery function button on the toolbar and double-clicking on the search text in row function. Next, let's set up the function to check all fields for equality. You can do this with a sum expression. Delete the existing expression and create a new one which checks each attribute against the search text. The sum expression will take each attribute, set it to the attr variable, and then check to see if any of them satisfy the match expression, which is an exact match in this case. Click OK, save, and run the simulator. Once again, we can search for market volatility and get the exact same result. But notice that we still had to delete the trailing space due to the need for an exact match. This time, however, we can also search for additional fields. Enter 1992, the year this book was published. Notice that we get 2 books listed this time. The app is getting closer to meeting our requirements, but isn't quite there yet. Close the simulator and let's make some more changes. Once again, go ahead and edit the search function. We will make one final edit to this search. Let's modify the function to search for any text which contains the search text. This can be done by replacing the existing comparison with a contains function. The contains function will search for the specified needle, attr, inside the haystack, search text. While we're here, let's also make the search a bit more user-friendly by trimming white space from the query and making the search case-insensitive. Instead of using the search text directly, let's store it in a variable at the top of the function. Use let to define a new variable. Unlike other languages, you will need to use a colon in front of the equal sign to denote assignment. Using just an equal sign would result in a Boolean comparison. Once a variable is assigned, the return keyword must be used. Place this after the variable assignment. Replace the search text reference in the contains function with this new variable. The reason we are using a variable is to make it easier to compare a modified search string with each attribute. Use the xQuery functions trim string and lowercase to trim whitespace and set the entire string to lowercase. To do this, we will also utilize the arrow operator. The arrow operator will take the value from the left side and set it to the first argument of the function on the right. This makes it very simple to chain functions together. Start with the existing search text element, then add the trim string function, followed by the lowercase function. The last thing we need to do is apply the lowercase function to the attr variable. Make this change, click OK, and then click Save. Run the simulator for a final time. Start typing market volatility and notice that the results are changing in real time. Try a few more combinations to verify that your app functions correctly. This tutorial covered filtering results within your mobile app without any calls to the backend server. Additionally, it also introduced the use of user-defined xQuery functions as a way to centralize logic and streamline development. Future tutorials will go in-depth on SQL-based filtering of results. MobileTogether Designer is a free program that allows anyone to create mobile apps for any platform. Visit www.altova.com/mobile and start creating apps today.